for having me back at Data Toboggan as well. Today we'll talk a bit about Fabric and some of the new data science functionality we have, with a bit of a controversial question of, do data scientists actually care about Fabric? So before we start, a bit of a brief introduction to me and Alex. So I'm Tori Tompkins. I'm a senior data science consultant. I'm probably a bit of a jack of all trades now at the moment. It seems like recently anyway, having primarily had a bit of an MLOps background, but now working a lot more in Gen AI as well. Oh, and yes, I am also a recent MVP. Alex.
Yeah, hi, I'm Alex. I'm also a senior data science consultant. I've been working as a sort of machine learning engineer / data science consultant for about 5 years. I've worked across sort of a number of industries, tackling the age-old question of how do you productionize data science?
Thanks, Alex. So just a quick look at what we talk about over the next 45 minutes. I will cover very, very briefly what Fabric is, given the conference we're at and the absolute plethora of Fabric talks that you've got. So I'll cover that within 10 seconds probably. I'll also introduce you to the data science ecosystem and what data scientists typically look for in a tool set. Talk through how Fabric have tried to tackle this problem and try to fill the gaps of that ecosystem. And then I'll pass you to Alex for some of the more practical fun stuff around structuring a data science project, a bit of a demo of data science in Fabric, and then we can talk about what's missing. So my promised 10-second introduction of Fabric. Ta-da! So this is Fabric being the kind of the new one-stop shop for all data analytics. It's really done very similar to what Synapse is doing, but probably a lot better, which is take all of the software as a service, so data factory, data warehouse, Azure machine learning, and put this all into one place underpinned by one lake, which I'm sure you've all heard about. Awesome. So let's get stuck into some of the data science stuff. I'd like to introduce you to our data science ecosystem. And I've tried to fill this all with lots of logos from Azure that you, if you're a data scientist, are probably familiar with. If you're a data engineer, you're probably also very familiar with. But this is our data science ecosystem. So along the top, this is split into 4 sections, but there is a sneaky little section at the bottom called Evaluate. And these sections all represent parts of the MLOps lifecycle. That being the explore phase, where data scientists will experiment with different models. You then have the evaluate phase, which is a phase dedicated to making sure that you're hitting the business value, you're getting the accuracy you want, you're reaching success criteria, as well as an important part which is often missed, which is around responsible AI. So making sure that your models are interpretable, making sure they're fair, that you're putting something great out into the world and not doing any harm. Then we have the develop and package phase at the top. And this is a phase around making sure that your model is appropriately wrapped and packaged so that when it gets put into production, it doesn't just immediately fall over. We have the deploy phase, and then we've got the monitor and integrate phase. So that's everything once your model's in production going onwards. If we were to dive into these boxes into a lot more detail, going back to the explore phase, this has been split into 4 main areas, just because there's absolutely tons of stuff covered in here. It's probably the biggest stage in data science and machine learning. And I've split this into 4 different categories. So you've got your traditional data science and machine learning, you've got your deep learning, you've got your AI, so vision, computer vision, and then the new buzzword, which is Gen AI. So everything involved in Gen AI. And this is a bit of a look at some of the libraries and some of the technologies that you might be familiar with. So scikit-learn being a very popular one, TensorFlow, PyTorch being popular deep learning libraries. AI in Azure is very much dominated by Azure Cognitive Services. And then when we look at Gen AI, you're looking at Azure OpenAI, Dolly within Databricks, and LangChain as well. Just below that, I also have low code and AutoML. And if you're familiar with this is like the new citizen data scientist. So these are the technologies that allow you to have a very low code drag and drop approach to data science, and also AutoML, your automated hyperparameter tuning and model selection. And in Azure, the options you've got Dataiku, but you've also got Azure Machine Learning and Databricks as well. If we cover the top, our contenders for model registry and feature store, Feast and Databricks are the most dominant feature stores within Azure within the Azure platform. But then you've got also MLFlow, which if you're a data scientist or you're data science adjacent, I probably don't need to introduce. It's the bread and butter to model registry and model tracking that Alex will cover in a little bit. We have frameworks as well. We've not got a huge option for frameworks at the moment, but BentoML being a very familiar one around wrapping up your models and preparing those for production. When we look at evaluation, just to briefly cover the responsible AI, because this will hopefully pop up later, we've got EcoML, InterpretML, and FairLearn. These are all very popular libraries for evaluating different areas of responsible AI. And then when we look at deployments, you want to take your model, you want to put that in production, you want it to be used by your end users. Your options are batch and real time. So batch is when you would want to score all of your rows at once, offline. And then real time is real time. So this is something you send your results one by one, or maybe in micro batches, and you want to get your results instantly as well. So we've got a couple of options in Azure for both of those. We have Azure Machine Learning and Databricks are good all-rounders for both, as well as Azure Functions, a far more managed version. We also have Fast API, which is a framework for APIs, and Kubernetes as well, which is the container service. And if you're familiar with the Fabric logo, you'll also notice that Fabric is within Batch. And Alex will cover in a little bit around how you use notebooks within Fabric, and that's how you would score in Batch. And then a real brief look of how monitor and integrate looks. Monitor around making sure that your models, the latency is great, but also the accuracy isn't decaying. We've got AML and Databricks in there. And then when we look at the app integration, so what we want to do further down the line, you can host models within Streamlit, or maybe you want to do model scorecards or model results within Power BI. So that was a real rush through the data science ecosystem there. So how does Fabric approach this? How does Fabric contend to those that I talked about? So the main thing that I want to talk about is SynapseML. So this is previously known as MLFlow Spark, but it's really around building machine learning libraries on top of the Spark engine, which Fabric and previously Synapse was based on. And SynapseML has a load of great stuff that you can work with your classic classification, regression, anomaly detection, time series problems within machine learning. So this is probably what you'll leverage most when working with data science. When we talk about the deep learning section part of that, the three main libraries come to mind. If you're familiar with deep learning, ONNX is a model persistence library, and SynapseML supports reading in pre-made ONNX models for you to use, score, and batch score with. But also want to highlight as well PyTorch, the popular deep learning library. You're able to work with Horovod, which is a distributed deep learning library. So by leveraging the two of them together, you can actually run and train neural nets on the Spark infrastructure that's within Fabric. When we talk about AI, I mentioned before that this was very dominated in Azure by cognitive services, and this is exactly the same within Fabric. SynapseML has its own integration within cognitive services. So if you have that spun up in your infrastructure, then you're able to leverage that within Fabric. And to really briefly go through what that offers, you've got all your vision, so computer vision, OCR, face detection, you've got speech, so speech to text, pronunciation, assessment, you've got language, which is all your translation, and then web search and decision, which covers the rest, which covers like anomaly detection and the like. And then the final box in that Azure ecosystem was the generative AI. So Fabric now works with OpenAI. You can leverage the OpenAI SDKs within Fabric as well. So this is a really good solution. If you're diving into generative AI, you already have Azure OpenAI spun up. You're able to run those SDKs and work with that. And do all your data wrangling within Fabric, and then send that off, get your results with Gen AI, and bring that back. And then the final thing I wanted to talk about that ecosystem before I pass you to Alex is the responsible AI. So I mentioned those logos earlier, so Econ, ML, Interpret ML, Fairlearn. Microsoft has put a load of great investment into responsible AI, and these dashboards were originally created from AML. And the wonderful thing about Fabric is it's now leveraging all of the work that Microsoft have done and all their other resources and pulling it all together in one place, right? So now you have access to running these dashboards within Fabric. And just a quick look of how that might look. This is the Error Explorer from the Responsible AI dashboard. And you can pull these more dashboards in. It's a GitHub project. Pre-install it, and then you've got all of these toolkit at your hands within Fabric, nice and easy. Alex, can I pass to you to talk about model registry?
You can indeed. So now that we have gone through some of the sort of tools for creating models, traditional Gen AI and all that good stuff, we get into sort of model deployment and experiment tracking. And I have up on the screen the sort of conversation which I had seen and had definitely been a part of a few years ago. I'm not embarrassed to say it, which is the sort of data scientist is a single person who sits within the company who works his wizardry from some little notebooks that he runs on his PC. And then anytime someone needs the model running, it's, oh, here's some data. Can you run the model? And then you run into a whole bunch of problems as soon as you try and turn that into some sort of productionization solution. So if we flick onto the next slide, that's sort of sending someone some data, running some code that's still on your PC and sending the output back. Asks a whole load of questions. The most important one is which data set was actually used to train this model. You know, you can have someone who's naming their files with or naming like model pickle files with the name of the data that they used, but it's not very robust and it's not a particularly good way to do things. Then also, if a model is a pickle file and you've been using it for 6 months, you might forget what model it actually is. You know, was it a logistic regression? Was it a random forest? How are they going to know? And then, okay, cool. We've got this fantastic pickle file. It's been doing great. I accidentally deleted it and then accidentally emptied my recycle bin. So that model's gone. But don't worry. I think it was a random forest. I can just train another one. But if you spent sort of 3 weeks doing hyperparameter tuning, refining how you were building the model, testing lots of different experiments, essentially with the death of the model and the loss of any notebook that was used to train it, that's gone. And that work all has to be reproduced, which is honestly a little bit dull and quite sad. And then, you know, if you've got 5 different models, you might have a spreadsheet with your model results, but how do you tie that to each of the models that you've trained and the various files for how you're deploying them? It's not a great way to sort of choose the optimal model. And then also you're trying to convey this to a team. They might not be other data scientists. They might not be particularly technical. It all becomes very tricky and a giant quagmire very fast, which is where MLFlow comes in. If we go on to the next slide, so MLFlow outside of Fabric is an open source platform for managing end-to-end machine learning lifecycles. And as part of Fabric, you have access to that. And so the sort of key things that we care about are being able to standardize the format of models, and then also being able to register and track them along with experiment tracking. So when you are in Fabric or Databricks or wherever you are and you've got MLFlow, essentially you can start an MLFlow run, and anytime you do anything, that is all logged into the model registry and the experiment tracking. So every time you train a different model, you get a snapshot of it, you get a packaged version of the model, you get all of the hyperparameters that you've used. If you're training with a validation set or using a test set, you get all of the performance metrics that you want for that model. They're all stored in one place, and it makes it very easy to share across your team. if you're multiple data scientists, how all of your models are doing, so that you can contrast and compare and choose the best one for production. And then it also allows you to sort of have version control and have a little bit more rigor around how you deploy them. So you can sort of set a specific version of the model, whether it be model version 4, to be the one that goes into production. And then you can continue to experiment with the same model. You can make a version 5, a version 6. And then you go, right, cool, we're now happy with this newer version of the model. We've done more tuning. You have the ability to essentially just swap whatever your deployment option is to look at a newer version of the same model. You don't have to deal with sort of re-embedding pickle files into a container or anything like that. You can dynamically pull all of the stuff into MLFlow, and it's a sort of key tool, I would say, that makes any sort of data science project click. And the fact that it's involved in Fabric sort of really takes it to the next level to be a viable tool for data science projects. So if we go on to the next slide, I'm going to talk sort of how to structure a very traditional data science project. I could speak for hours about how to do it and all the sort of different steps and variations, but we're just going to look at sort of your bog standard regression or classification project, the various elements of Fabric that make that easier, and sort of go through how you would do that. And then once I've spoken about it and bored you all a little bit, I'll go into a live demo, which should hopefully show it in practice. So if we go on to the next slide, we will look at just the sort of overall architecture. This is what Microsoft say the sort of data science architecture is. So I can't take credit for the pretty diagram, but I think it is a really nice and simple way to sort of lay out what you're expecting in a data science project. It sort of simplifies the very large ecosystem diagram that we saw at the start down into its core components. So you start with a Fabric lakehouse or a data warehouse of your data. You can quite simply write some notebooks to clean and prepare all of the data. You can then store that data once it's prepared and ready for training. You then get the fun iterative process of training new models, testing them, going back, doing it again, finding the optimal model, and then you can track and store all of that in the model registry as part of Fabric. And then when you have a model that you think is ready for production, you have sort of an easy way to have all of that within Fabric. You can write out results that have been predicted back into a lake warehouse, or you can have it in Power BI to have your model scorecards and things like that. So I'll break down the sort of key steps and the things that I find really exciting about data science in Fabric. So if we go on to the next slide, you have the lakehouse, which is kind of the whole point of Fabric. It's a big lakehouse solution, and it is very useful. The fact that it is a data architecture for storing, managing, and analyzing structured or unstructured data in a single location, and Fabric does a really good job of making that sort of seamlessly integrate with everything that you want to do. So if you haven't used or seen Fabric before, I just have a screenshot of a lakehouse that I spun up, and you'll see some of these files in the demo a little bit later on, but you've essentially got your tables and then your file store, and you get a nice little explorer built into Fabric in your web browser so that you can have a look at your tables, have a look at your files, and have a sort of click-throughable, that's definitely not an English word, view of looking at all of that data and seeing what you've got there, and then it will integrate seamlessly into all of your notebooks. So if we zoom on to the next slide. Yeah, that is the notebooks themselves. I tried to find a quote from Microsoft to describe the functionality of all of these different parts, but there really isn't anything particularly fancy about notebooks. So I decided to make something up, which is notebooks. You know them, you love them, they're notebooks. They kind of do what they say on the tin, but they're an incredibly useful way to give information around what you're doing and sort of the logic of your experiment. And the Notebook Resource Explorer within Fabric gives a sort of an additional thing, is it's got a Unix-like file system to help manage folders and files. So outside of the Lakehouse, you've also got the little resources tab so that you can store code modules, models, images, and anything like that. So you can easily access them within your notebook as if you were working with a sort of a local file system. And I think you get about 500 megabytes of storage in there. So you get sort of tons of space to store all of the things that you would need within sort of notebook and that general environment. You can sort of perform common operations like create and delete, upload and download, and then you can also sort of drag, drop, rename, and do all of that stuff through it. It's sort of easy to use the paths for it, so it's generally the path would just be built in myfile.py or whatever it might be called. So you can very easily integrate it into all of your code. And then anything you've got there can very easily be sort of moved into the Lakehouse via some of the write to Lakehouse functionality that's built in. So it's pretty cool. It's just a notebook, but it does have some nice extra features along with standard notebook stuff of being able to have your markdown in there so you can kind of explain your logic. And in Fabric, they currently support Python, Scala, Spark SQL, and R, and all of the Spark versions of those for that distributed computing that you all know and love. If we fly on to the next slide, you then have the Data Wrangler, which is a sort of nice hybrid between a drag and drop sort of data management interface and sort of auto code tool. So when you open up the Data Wrangler, essentially you can choose any data frame that is currently saved in your notebook, and you get a ton of options to sort of look at some summary statistics of the data and sort of dive into it a little bit more than just sort of displaying the data frame or running a few pandas commands. It's got some built-in visualizations for each of the columns, and it will automatically sort of show the appropriate graph based on the data type. But the really good thing about the Wrangler, and I think why it gets this name, is it's got a pretty huge library of sort of common data cleansing operations built into it. So you can one-hot encode your data straight from the Data Wrangler. You can drop missing values, you can drop duplicates, sort of do column manipulation. There's probably 20 or 30 different tools you could do. And if I had them all on the slide, it would probably be a massive table and quite dull to look at. And then what you do from essentially selecting and creating your order of operations, you just generate code that inserts itself into the notebook that you can then run. So you only need to data wrangle once, and then once that is... My headset was talking to me. Yeah, so once you have done that, you generate the code inserts itself into the notebook, and then rather than having to, every time you go into a new project or a new data set, go back through the Wrangler, you've got that Python code which has been written for you. You can just run the notebooks. So it's a sort of wrangle once, run infinite sort of job, which is pretty useful. And they generate the code both for pandas and currently in public preview for Spark. So you've not only got something that generates code, you've got something that gives you options of what code you want to generate, as more is always better. And then we will go on to the second to last part of the project structure, which is the model tracking. So I've kind of covered it a lot in my very infused rant about how fantastic MLFlow is, but it's worth taking a little bit of a look at the interface that you get. So I spun up a sort of very basic model. And you can view in your sort of experiment tracker all of the runs that you have done down in the sidebar. So when there are sort of more runs in there, you'll have a big list. You can easily see all of the sort of runs and experiments that you've done. You get a sort of panel where you can track the model. You get a lot of information. So in there, you've got a source, so you can link right back to the notebook that trained the model. So if you're, in a team of data scientists, you see a model with particularly good performance, you go, oh, that's cool. I want to look at what they were doing there, what data they were using, everything like that. You can go straight into the notebook. You can see where it's been built from. You get all of those sorts of visibility options. You then also get a run ID and sort of version numbers and things like that. So if you're looking to deploy them, you can go in there. You can get the run ID for the specific model you're looking to deploy, whether it be to an endpoint or for batch inference and things like that. So you kind of have a one-stop shop in your Fabric one-stop shop for all of the information you need to know about your model. And then, like in traditional MLFlow, you get all of the information on the hyperparameters and the performance and things like that, just so you can easily see how well the models are doing at sort of cursory glance. And Fabric also has a run comparison tool built in, so you can select a few different models or runs and you can compare them all at once if you're looking to make the solution, make the decision as to which model is the one you want to bring forward into production. And then last but not least, we have, if we could go to the next slide, sort of the way to do inference within Fabric. So at the moment, it supports batch inference, and it has you can operationalize machine learning models with a scalable function called predict, which supports batch scoring on any compute engine. So very quickly, before we talk about the sort of predict function, just cover what batch scoring is. So batch scoring is essentially where you have a large chunk of data and you wish to run it through the model all in one go to predict a certain value for all of them. So classic examples of this is sort of churn prediction, credit risk analysis, forecasting. So you don't need to be doing it in real time. So you don't expect to get sort of a single row of data in and then provide a very fast response. It's information that you might build up over a period of time, generate all of your predictions on in one go, and then action the insights that you get from the model predictions. And so being able to do that and use this sort of predict function, you get the ability to build very nice notebooks where you can load in sort of unseen data. You can load that from like a Delta table or from the Lakehouse. You can build one of the different types of predict functions very quickly and very easily, score all of that data, and then write that back out into the warehouse where it can then be ingested by Power BI or sort of data analytics team to kind of look at it and make use of the insights that you're generating from your models. So the three options you get are you get the Transformer API from SynapseML, you get the Spark SQL API, and then you get sort of user-defined PySpark functions called UDFs. And in the demo, I will go over the Transformer API for SynapseML. So if we fly onto the next slide, it is time for the demo. I will go over sort of using the Lakehouse, using the data wrangler, very, very briefly training a model, and then sort of go over the experiment tracker and how you can deploy the models to batch endpoints. I'm making the claim that Fabric is super simple and easy to use. So I haven't blue-peated this demo. I've written a few notebooks, but I've deleted all my lakehouses, I've deleted all my experiments, and I've deleted my model. So hopefully, if everything goes well, we should be able to run it. And then in real time, you'll be able to see how easy it is to sort of get a data science project on the go using Microsoft Fabric. And if it doesn't go well, then I will have to improvise. So when you load up Microsoft Fabric and create a workspace, you get this sort of UI in front of you. Tori, is my screen sharing okay? Yeah, I always get worried that people can't see what I'm doing. Good, thumbs up. So you get this sort of interface where you can create a workspace for your particular project, and then sort of a nice clean layout. You have the option of an absolute ton of things that you can create, but for now, we're just going to focus on notebooks because they are the data science bread and butter, and we should be able to do everything we need from the notebooks, and then just take a little dive into models and experiments, which we can create through these tools. So the first thing you do when you jump into anything is you need to create and add a lakehouse. In Fabric, that is an incredibly easy process. You hit the add button, and then you can add one of the existing lakehouses you've already created, or you can create a new one through the menu. So I'm going to be super brave, and I'm going to do everything with a new lakehouse. So I am going to call it Super Cool Demo and hit create. And just like that, hopefully, we have a lakehouse. So you can see there that we've got this sort of basic lakehouse structure with tables and file systems, and they are currently both empty because we haven't done anything. And so very briefly, what I'm going to do is I'm going to load up the sort of bank churn data set, which is a very commonly available sort of data science classification data set. And we are going to load it from a bucket, and we are going to save it into, or a blob rather, and we are going to save it into the lakehouse. So these sessions may take a tiny bit of time to start because I'm connecting a lakehouse to them for the first time. So while things are loading and running, I will take questions from the chat if anyone has any. Or questions for Tori as well, to put her on the spot. It's not a question, but it's a fantastic endorsement for Fabric, and it is, very well designed to be a sort of easy to use environment. You can set up your Fabric sort of compute, and then everything is under the hood and sort of done for you. Yes, so once a model has been stored within the sort of MLFlow model registry tool, you get all of the options to sort of export it, because MLFlow, what it does is essentially it packages a model up into a sort of predefined state. So once you have registered your model in that way, you can very easily download it as a .pickle file, and it comes with all of the stuff you expect from MLFlow. So it comes with code to run it, it comes with the requirements.txt and everything like that, so that you can sort of reproduce the model across different environments. It is thinking really hard. So clearly one of the slight shortfalls of Fabric is when you are starting a session and connecting to your lakehouse for the first time, it does take a hot minute. But hopefully in just a second, it should be done. I'm just going to get all of the other notebooks waking up while we do this to try and save a little bit of time later on. What did I call it? Super cool demo. It is still thinking. My Fabric capacity is still definitely turned on. So it is just trying to show me up. Ah, there we go. It looks like we have success. So our session has woken up, and now what we are going to do is we are going to download the data from a blob store, and we are going to save it into the file system. So I won't go too much over the code because it's all sort of fairly standard data science stuff. But we're essentially doing a little bit of defining file paths. We are setting a remote URL that we want to pull data from, and then we are using the writer or using the write function to just write the content that we have pulled from the UI, from the API into the data lake. So when I hit refresh there, you can see that now we have the churn data in the specified folder. And when we look in there, we can see that we have our CSV saved in the data lake. So we can move on to the next step, which we've got our data, we've ingested it, it's in the data lake, we want to wrangle it. So step one is going to be to load said data. This is going to do exactly the same thing again and start the session. I didn't consider this when I didn't do my Blue Peter demo, so I shall have a look back to the chat. Let's see what the questions are. Will you be using a pre-existing data set? Yes, I will. I'm going to be using the bank churn data set. Does the data wrangler modify the data structure of data set? So it doesn't necessarily sort of change the data set as it is stored. So what I'm going to be doing is I'm going to be essentially storing the data set in the lake as a file. Then I'm going to load it into the data wrangler. I'm going to wrangle it. I'm going to do a few bits of cleansing and operations like that. And then I'm going to write that out to a table, again in the lake house. So it won't mess with sort of initial data. So every time I do operations, I'll be writing it back out into the lake house and essentially storing the different versions of the data there, just so we can make sure that we're sort of consistent in the data sets that we use when we're training models. So if we sort of do an update and train a different model, we've got a different table that we're reading from, so that if we want to sort of reproduce this, we can take all of the same steps across. Have I integrated PromptFlow or semantic kernel with Fabric? Not currently, but it is something that I'm very excited to do or look at in the future.
On that question, PromptFlow is going to be miles easier to integrate than semantic kernel, being that we've got the OpenAI integration with that as well, and the AML. So using PromptFlow within either of those, you will be able to create them in advance and then call them from within Fabric. Semantic kernel, I think, is going to be a little bit trickier.
Cool, there we go. This one has woken up. So now we can see that we have some Spark jobs running in the background. And we have loaded it, so we can do sort of standard operations like displaying the data set as a data frame. And now, if we go into the data tab at the top, we get a big option there, which is called transform data frame in the data wrangler. So what we are going to do is we're going to scroll down a little bit, and you can see here that there are two sections of Markdown which do not have associated code. So what we're going to look to do is generate the codes to perform these tasks using the data wrangler. So the first thing we're going to do is just some very basic cleanup operations. So we're going to drop duplicates across the columns row number and customer ID. We're going to drop any missing data across the entire data set, and then we're going to get rid of customer ID, row number, and surname because they won't provide any sort of meaningful or useful information to the model training process. So we hit the drop down there, and you can see that the very poorly named data frame DF exists within the context of this. And so we can go into the data wrangler, and we see this fantastic tool here. So you can see once things load up that we have all of the columns in this view. We can see sort of statistics on all of the columns. We can see the distributions and the graphs and things like that. And you get a very easy view. So you don't need to write sort of lots of matplotlib, pyplot, seaborn stuff to view the data. You can just load up the data wrangler and do a lot of that analysis here. But we're not here to look at pretty visuals. We are here to use some of the operations and clean the data. So the first thing that we want to do is we want to drop duplicate rows. So we go into the list of operations, we select the operation that we'd like, and then you can select the columns that you want to run it on. So we are going to drop the duplicate rows across those two categories. You can see it has already generated the code for us here. You can see it's highlighted the columns that we want, and quite simply by clicking apply, it will add that into, by clicking apply, there we go, it will add that into our order of operations and our cleaning steps. Next, we want to drop missing values across the board. So what we're going to do is we're quite simply going to go into the drop down. We're going to select all rows, give it a second to load. You can see again, it's generated that code. We can hit apply, and it will drop the missing values for us. And then finally, we want to just drop a few columns altogether. So you can select them all, holding control at the same time, just to pick all of the ones that we want. And then you get a little option there, which is drop columns, which will add a new operation. It will think for just a second, and then boom, we have the code done to do that. So none of this is particularly sort of complex stuff, but this is just a very basic example. When you're training together lots of operations, it can become very useful to sort of have a methodical step-by-step view how you're doing everything. So now I have applied that. We can finally click add code to notebook. And what happens here is it will generate the code for us. So I'm going to be, even though it showed the pandas code, which is a little bit confusing, I'm going to be using the PySpark example that it generates. So I can add that to the, there we go, add that to the notebook, and you can see that we've got our function here. So we can run that, and you can see that the Spark job starts. And just like that, we have the new clean data frame with very little effort. I'm then going to very rapidly do the same thing again to one hot encode geography and gender. So I can go into df clean, I can go into formulas, I can go into one hot encode. I can, yeah, there we go. And you can see here as well that it's a smart tool. So it's not allowing me to one hot encode columns that don't have the correct data type. So I can select geography and gender. It will think for a second, and then I can hit apply and get that done. That has been done. Add it to the notebook. Again, we'll use the PySpark code. That is in there. It wasn't there before. Feel like a magician. And then run that, and we should have some nice one hot encoded data in just a second. Cool. So we can see that we have done all of that. It's generated us some nice sort of runs as well, so we can look at what has been going on in the Model Explorer, and then we are going to write that to the table in Delta Tables as our clean data ready for training. I have also noticed that I am rapidly going towards the end of time, so I'm going to refresh this, and there you go. You can see that we now have a Delta table of the clean data. So we're going to do things slightly out of order. I'm going to pass back over to Tori to do the last few slides that we have to talk about. I'm going to run everything in the background so you don't have to watch all these sessions start up. Then we'll cut back to the demo for the last sort of minute, and I will go over training a model, deploying a model, and looking at the model registry tool. So Tori, over to you.
Yeah, let me whiz through the last few bits. Awesome. So we've talked about all the great things that Fabric can do for data science, but in context of the things that perhaps it's missing, I thought a good thing to do is to bring up the ecosystem again and remove everything that isn't fully integrated into Fabric. And this quite clearly highlights the areas that it's missing. And no one expects every tool to hit every point, but there are quite a few tools out there that are trying to. And I think a great thing for Fabric would be is also join that, especially if the plan is to be the one-stop shop for all analytics. You can see Fabric does a really, really great job at the explore phases, bringing in all the libraries and the wonderful stuff that Azure does in AML, cognitive services, Azure OpenAI, and bringing that into the Fabric ecosystem. What it doesn't do so amazing with is when we look at the later stages, the more MLOps focused stages, which is the deploy, monitor, and integrate. And while we do have integration with Power BI, which I believe is being covered in quite a few sessions today, with deployment, your only real option is what Alex will show you in a bit, which is notebooks or batch predicts. When it comes to real-time scoring, which is a requirement for quite a lot of data science projects these days, you've really just got no option in Fabric, which is quite surprising because there's quite a strong option within Azure Machine Learning. What you need to do is what Alex mentioned earlier, is to leverage MLFlow, bring your models out of the system, whether that being as you've pickled it, and then leverage other tools to fill that void that Fabric has left. Yeah, quick wrap up. Fabric does really well, the modeling, the wrangling, and the model exploration phase. Stuff that the Fabric is missing currently is those real-time endpoints, is some sort of feature store, and basically most of the MLOps orchestration as well.